Hi guys, today we will discuss about the microservices architectures and its principles. Guys, you need to understand when we develop any systems, we need some technical design architectures. Uh, by using this, we can develop our systems. So in market, there are so many architectures, technical architectures, like monolith, service-oriented architectures, and as well as microservices. So, before going to microservices and microservices architecture, we need to understand what is monolith and the service-oriented architectures. Monolith and service-oriented architecture, it has some drawbacks or some issues. That's why we introduce microservices architectures. So now guys, let's understand what is the monolith architectures. Now let's understand what is monolith architecture. Monolith architectures is it also it is a type of architecture, but it has some drawbacks. Then we use a micro. Then the market use a microservices. So now let's understand three examples. We have one projects and in our projects, you divide in some different in components. You divide your project, large project, in some components, and uh, and here you have to provide some services. Like some, you can also call it as a services. Like in our projects, we are using uh, some some services like validation service. And next one, process service processing. And next is Stripe API service. We you divide your projects. You divide your large project in a small components. And here you have in validation service you write some logics, some business logics, as well as and in processing service you can also write some logics and execute these services. And also same as it is a Stripe API service, you can write some APIs related logics here. But the question is where we run this all the services. Mm. Uh, the when we run the in monolith architectures, when you divide your big projects in a small services, but at the time of running, you run your projects in a same service in same processors, like one processors, and you run these three different components or services in single processors. So when we run your big projects in a limited capacity of processors, then it may be your large projects. Uh, Maybe it will be crash in single processor. It will be crash. So So that's why the this is the little bit the drawback of monolith architectures. Then the company or market will switch to the microservices architectures. Microservices architectures is developed by the is introduced by the Martin Floor and James Lewis in the year of 1990. Sorry, in the year of 1914. Microservices architectures. Microservices architectures is a way of designing software's application where we where a whole application is broken into a small parts and it run individually. In the beginning, the story is in the beginning, there are so much confusions. Which project is follows microservices architectures rules or something. So that time everyone's told I have created some projects by using microservices. So there was so much confusion was happened in beginning. So to remove all these confusions, Martin Lewis and sorry, Martin Martin Flower and James Lewis introduced some principles. Introduce nine principle. Those projects are follows this nine principles. Only you can say that this is developed by using the microservices architectures. And the nine principle are This is the ninth principle, which is introduced by the Martin Flower and James Lewis in the year of 1914. So, using this principles, we can say that this project is follows, and the project is developed by using the microservices architectures. It is not compulsory to use all the principle. Your projects follows all the principles. If your projects follows like 2, 3, 4, 5, then you can also say that your project is developed in by using microservices architectures. So now let's understand first principles. What he said. The first principle is componentizations via services. So the meaning of this principle is said means you can break this principle componentizations. Uh, this principle, first principle, componentizations via services, said that you can your big projects your big projects you divide your big projects in a uh, small components like that. Uh, you componentizations via services told like that you divide your big projects in a small components. Components means nothing but it is you can say like a servers or where services like here in each components we write some like your in all the components, we provide some related functionalities together. In validation service, what's the related functionalities will comes like your front ends like your validations like form validations, characters, so which type of characters, so like something will be comes in validation services, and in the second services is comes like processor. Here we have to write some related functionalities, which will functionalities and which we code here, and also we have to write in the third components like a stripe services, and here I have to put all the related functionalities like the stripe APIs related functionalities, you put in stripe services, and after that this all these services are run in individually, means in means it run individually. It not depend on any other services or processors to execute the all the programs or all the codes. It execute its own services, sorry, its own processors, and its own port number, and it so so it's not hectic to the processors, how much they how to run all these things, because all the services are execute in different and in its own proper processors and its own proper port number. So all the services are run in separate separate processor and a separate port number. So it's not hectic uh, to the one processor to run all these big projects. Uh, but now the question is comes when you divide your large project in small services. The question is comes in your mind, um, like questions like first is how you do these questions are comes in your minds, how do you prepare each components, how do you finalize which functionality code should be in which components, what is the size of components. There are so many questions that comes in your minds. So to solve all these questions problems, second principle is comes, and second principle is organized around business capabilities. The second principle name is organized. This is second principle. Second principle is organized around business capabilities, and it is also called as a business functions as well as business domains. Why it is called like that? So, when we uh, when we split your big projects in small components, that time you do not split your components by using your thinking process. You split your components based upon your technologies as well as features based and business functionalities based. You can split. So first understands this one. This is our project structures, all this is structure, project structures. This is a client. This is a payment verification systems. And this is Stripe payment service providers, and it is a banking service. So, um, so in our payment integration systems, we divide your components. You split your Stripe payment integrations projects systems in a small components like that. And in the component, you have to provide the like some first provides components like first services validation service, second one is processing service, and third one is provider provider services. uh, so here you have to split your projects in small components based upon your technology purpose and feature based. You can split in first component is comes like validation services, and second one is the processing services, and third one is comes like provider services. So you think like uh, according to this according to the functionalities or business functionalities based you related you together the all the components. So now the question is comes what type of functionalities will comes under validation services, processing services, and what type of functionalities this comes under in provider services. So in first we let's talk about the validation services. When we developed a validation services, inside this in this validation services um, your in this services um, validation services, your functionalities will comes under comes from validation functionalities comes like altogether like means for front end functionalities functional front end related functionalities will comes under this ones like field validation means form validations, business validations, characters, mean max, like like that. That functionalities will comes under in validation services. Similar as you can say about the processing services. Inside the processing services, you group by based upon the functionalities like core payment related functionalities will comes in core related functionalities will comes under in processing services like payment success failure, um, payment payment is success failed field related um, related functionalities or codes comes under in processing services. And when we talk about the provider services, inside the provider services, the functionalities will comes in under the provider services is stripe stripe related functionalities like stripe related functionalities will comes under in provider services like um, mm, like stripe related like stripe APIs like create session API keys APIs keys related logics is comes under in provider services. Based upon this functionalities, you group the all the validation services together. And now, when we talk about the size, when we talk about the size, what's the size of this all the services? So, we can, size here, size is not mandatory. You need you use some decent size uh, decent size and size should be just right, not too big and not too small. So uh, the benefit of this, when we wants to add some things else more in future times, you can put easily where according to the functionalities of the requirements, you can put in which services you want to add. Easily you can find if you write in a related to the front end related functionalities, then you can put in a validation services. So uh, so if you fix your size, then it will not occupy too much space. Or if you want for in future you want to add some logics in different way, then that time you do not put any logics. That's why size is not mandatory. So your all the services is developed in different projects, and it runs in separate processes and its port numbers. But the question is comes when the question is comes when validation service wants to call some functions within processor service or provider services, type provider services, then how it will be happen. So they solve these problems. Third principle is comes. Third principle is comes. For third principle is smart endpoint and dump pipe. This smart endpoint dump pipes principle is comes to solve this problems to communicate one services to another services. Dump pipes means it is a connecting pipes means the systems like validation service systems is connect to the systems like processing services, and the processing services is connecting to provider services and communicate and call the functionalities to each others. Now we understand the dump pipes. Means how the dump pipes will works, how it one services will communicate with another services by using the pipelines. It is work like a pipe to communicate with one services to another services. But here is a smart endpoints and dump pipes. Smart endpoints means you dump your your every uh, logic business logics or logics in here could keep them in different services where we want just lightweighted your pipes, not to complicate your uh, pipes, just to dump your uh, business logics or logics in dump to dump this in different services where we want to communicate. Why smart endpoint and dump pipes concept is comes before we understand the smart endpoint dump pipe. Before at the time of SOA, that time we also you communicate with one services to another services, but that time we cannot communicate with one services to another services directly. That time you have a one intermediates like ESB. ESB. That time we have to first we have to communicate with one services. First communicate with ESB. Then the ESB will communicate to another services. ESB stands for Enterprises Service Bus. It is work like a bus, means one service will send the response or call first to ESB, then ESB will call the respective services and then they give the response back to the services. That time it's too much hectic to handle this ESB. So that's why the microservices was introduced, the smart endpoint dump pipes. So the microservices introduced the smart endpoint and dump pipes means to let's understand through one examples. Means one services can communicate with another services by using the dump pipes to dump this all the source codes in through these pipes to communicate easily way and smooth way. Uh, so so this is how this is happening by using the help of REST REST over HTTP. By using this REST over HTTP, this one service will communicate with another services. So there are two types of communications. First one is async and sorry, sync and async. There are two types of communications, sync and async. Now let's understand what is the sync communications and async communications. Let's take an example. This is a sync communications and this is a Async communications. Now let's understand how the async communication will work. So you have two services like M1 and here you have a M2. M1 wants to communicate with M2 means how it will be happens. First, some M1 got some request and after that he wants to communicate with M2 further. Then later M2 will process the request and then it gives the response back to M1, and then further M1 will process the executions. This is the flow of synchronous communications. Means one request will go to M1 and then he communicate with M2. After M2 will execute and then give the response back to M1, and then further M1 will execute our executions. So here M1 will M1 will dependent to M2 to first to complete their executions, then to give the response back, then further I will do the work. So and it's happening in sync communications. And now let's understand the async communications. Here you have a uh, service, and here you have another service. M1 and 2. So same processes happen. M1 got some request and then further M1 wants to communicate with M2, comes back to the M2. Then later uh, M1 will not wait for the M2 to first execute, then response back to M1, then further it will work. Uh, M1 sends the request to the M2, then uh, after they start their further executions, they are not waiting for the response for the M2, and when M1 gives the response, like later they give the response, it will M1 M2 will give back the response to M1, then later they will start the work or further. They are not stopping their works. M1 will not stop their works. So for the reason of M1 will not start or still not giving the response back, they don't want to the response, but they further start the executions. Our executions, they are not waiting for the M2 response. They continue their execution continuously. So the question is how sync is um, not stop their executions, because the one intermediate is present in async, like so the microservices introduce the smart endpoint and dump pipes. Means to let's understand through one examples. means one services can communicate with another services by using the dump pipes to dump this all the source codes in through these pipes to communicate easily way and smooth way. Uh, so so this is how this is happening by using the help of REST REST over HTTP. By using this REST over HTTP, this one service will communicate with another services. So there are two types of communications. First one is async and sorry, sync and async. There are two types of communications, sync and async. Now let's understand what is the sync communications and async communications. Let's take an example. This is a sync communications and this is a async communications. Now let's understand how the sync communication async communication will work. So you have two services like M1 and here you have a M2. M1 wants to communicate with M2 means how it will be happens. First, some M1 got some request and after that he wants to communicate with M2 further. Then later M2 will process the request and then it gives the response back to the to M1 and then further M1 will process the executions. This is the flow of synchronous communications. Means one request will got to M1 and then he communicate with M2. After M2 will execute and then give the response back to M1 and then further M1 will execute our executions. So here M1 will M1 will dependent to M2 to first to complete their executions, then to give the response back, then further I will do the work. So and it's happening in sync communications. And now let's understand the async communications. Here you have a uh, service and here you have another service. M1 and 2. So, uh, same processes happen. Someone got some request, and then further, someone wants to communicate with M2, comes back to the M2. Then later, uh, M1 will not wait for the M2 to first execute, then response back to M1. Then further it will work. Uh, M1 sends the request to the M2. Then uh, after they start their further execution, so they are not waiting for the response for the M2. And when M1 gives the response, like later they give the response, it will M1 M2 will give back the response to M1. Then later they will start the work or further. They are not stopping their works. M1 will not stop their works. So for the reason of M1 will not start or still not giving the response back. They don't want to the response, but they further start the executions. Our executions, they are not waiting for the M2 response. They continue their execution continuously. So the question is how sync is um, not stop their executions, because the one intermediate is present in async, like mm, the intermediate called message broker. Message brokers. now Now let's understand how the brokers work in async communications. So I will draw once again the image. The message broker will works like mm, mm, message brokers will work like intermediate between M1 and M2. M1 and here is the M2. M1 will communicate, M1 is wants to communicate with M2. So if M1 is got some request, they send and wants to communicate with M2. They send the request to the message broker. Message brokers. There are so many types of message brokers at present, like active active MQ, Rabbit MQ, Kafka, Amazon Event Bridge. There are so many brokers are present in the markets. So M1 wants to get some got some request. and M1 wants to communicate with M2. So the M1 will first send the response to the message brokers, and here all the request is comes. Uh, Here all the request is comes, and after that message broker will sends the response. All the request which given from the M1 will sends to the M2, and after that M1 will sends the response back again to the M1, and then message broker will sends the response back to the M1, and then but in between this M1 will not stop their works. They continue our executions till the request is coming or not from the M2 sides. They are not stopping their executions, means not their stopping their executions till still M2 will not give the response back to or not, but further then it continue the executions. It's not wait for the M2 response. So this is how the M1 like async and sync communication will be happens. So, smart endpoint and dump pipes work like to do not disturb any third parties to directly communicate with the one systems to another systems. So, the sync and async communication will happen. In sync communications, M1 one service and M2 service. Here M1 service will got some response, and M1 will wants to communicate with M2. Then what? So there are two types of communication: async and sync and async communications. So in the sync communication, M1 and M2 you have two services, and M1 wants to communicate with M2. First, the M1 will got some response, and then he send the response, and also M1 wants to communicate with M2, and then he send the request to the M2, and then M2 will process the request. After the response given back to the M1, then after getting response, M1 will continue further our request. But in sync communications, M1 will not wait for M2 to, and he not immediately wants the response. So the intermediate works from between this M1 and M2 in the time and the sync communications. M1 will send the response before uh, sorry, M1 will send the give the response or send the response to message brokers. There are so many types of brokers, so that message broker will give the response which is given by from M2 to given by M1 to give the M2, and then if they're not current instantly, if they're not able to do the works or execute the request, then they will M1 will continue our further execution. They are not waiting for the M2 response, means in sync operations will happen like that. They are not waiting for M2 response. They will continue our further executions after M2 will, when they have to time to execute the request, then after they send the response back to message brokers, and message broker will send the response back to M1, and then further execution will be happens here. So in the smart endpoint and dump pipes is introduced for this purpose. means to communicate or to communicate with one service to another service by the help of um, uh, pipes. And here you have to write your some business logics inside your services and dump into the another services uh, without doing any complication, which is was happened at the time of SOA. So smart endpoints means it's all the responsibilities for the microservices to communicate with one service to another services means when we create a one services like using Java and when another services is using Python. So that time it has all the responsibilities means to communicate different language to each other, so by using the business logics which is dumped by the services.